Hi, everybody. It's Professor Mitchell. Today we're talking about section 1.3, collecting sample data. So these are different ways to do sampling. And then this will take care of chapter 1. And I'm really looking forward to the next chapter where we can start doing some actual problems. Okay. So key concept in this section, the method used to collect sample data influences the quality of the statistical analysis. Of particular importance is the simple random sample. Okay, I'm just going to go ahead and tell you what a simple random sample is. So it's a sample that's chosen completely at random where so let's say that my population is 10,000 people and I want to choose 100 of them. Simple random means that any group of 100 people has just as much chance of being selected as any other group of 100 people. Okay? Totally random. If sample data are not collected in an appropriate way, the data may be so utterly useless that no amount of statistical torturing can salvage them. Okay? All right. Randomization with placebo and treatment groups. You may have heard about those in your psychology classes. Sometimes called the gold standard because it's so effective. So in case you've never heard of this, this is where you take a group of people and divide them in half, all right? The typical example is you're trying to test a new drug. So you give half of the people a placebo, a sugar pill, something that looks like a pill but doesn't actually do anything. And then you give the other half of the people the drug, and you obviously don't tell the people, are they getting a sugar pill or a real pill? And you see if there's any difference between the control group, which is the group that got the sugar pill, and the treatment or experimental group that got the real pill. Okay, statistical methods are driven by the data that we collect. We typically obtain data from two distinct sources, observational studies and also experiments. So essentially an observational study is where you don't get involved, you just watch. An experiment is where you do get involved. You give people pills, for example, all right? So I think that's basically what the next slide is going to say. They start with experiments. So in an experiment, you apply some treatment and then proceed to observe its effects on the individuals. So these individuals are called experimental units. If they are people, they are often called subjects. All right, so then you have an observational study where you're observing and measuring specific characteristics without attempting to modify the individuals. So that's what makes it different from an experiment. In an experiment, you are attempting to modify the individuals. You're giving them a treatment, all right? Observational study, you're just watching, and you're not getting involved. Okay, here's an example. Ice cream and drownings. Observe past data to conclude that ice cream causes drownings. I enjoy this example because it's a good example of a concept that we math people and statistics people really like to talk about. So there are data showing that increases in ice cream sales are associated with increases in drownings. That sounds kind of weird. So the mistake is, so this is a classic example of correlation does not imply causation. They are not trying to, or at least I hope they're not trying to say, well, they are saying that though, aren't they? Observe past data to conclude that ice cream causes drownings. It's not that ice cream causes drownings. It's that hot weather causes both, right? Hot weather leads to more ice cream sales, and hot weather also leads to more people swimming, which leads to more people drowning. All right. So it's not that one of these things causes the other, it's that there is some third thing that causes them both. The lurking variable of temperature and the failure to see that as the temperature increases, ice cream sales increase and drownings increase. But one is not causing the other. Okay, so let's say that I was doing an experiment to see if ice cream sales cause drownings. So one group is treated with ice cream while the other group gets no ice cream. We would see that the rate of drowning victims is about the same in both groups. Okay, so when you do your, the point they're trying to make is that an experiment for this situation is a lot better than an observational study. Okay. All right. Design of experiments. So you have what's called replication. Replication is the repetition of an experiment on more than one individual. Good use of replication requires sample sizes that are large enough so that we can see effects of treatments. Okay? That's replication. Then we have blinding. Blinding is a technique in which the subject doesn't know whether he or she is receiving a treatment or a placebo. Right? We talked about that a few minutes ago. Blinding is a way to get around the placebo effect, which occurs when an untreated subject reports an improvement in symptoms. Sometimes that happens. You give a person a sugar pill, and if they think they're taking a real pill, they say, oh, all of a sudden I feel so much better, right? It's completely psychological. Okay, then you have double blind. This is a really, really good method for experiments. So this is where the subject doesn't know whether they're getting a sugar pill or not. And again, a sugar pill is just another term for placebo, right? And the experimenter doesn't even know. That's why it's called double blind, right? The subjects are blind and the experimenter is blind, all right? Because there is a possibility experimenters are human, right? And so if they know who's getting the placebo and who's getting the actual treatment, they might see some things that aren't really there. Oh yeah, this person seems so much better, but the experimenter knows that that person's getting a real pill. If you take that away, then you know, that's a really good thing to do. Okay, and lastly, you have randomization. Randomization is used when subjects are assigned to different groups through a process of random selection. The logic is to use chance as a way to create two groups that are similar. All right. So those are the 4 different kinds of designs of experiments. I think we might be able to squeeze one more thing in today. Let's see what it is. Oh, we've already talked about this. A simple random sample is a sample where, you know, and again, let's say I'm trying to pick samples of 50 people. Any group of 50 is just as likely to be picked as any other group of 50. That makes it a simple random sample. And sometimes simple random samples are just called random samples. Okay. All right. I'm actually going to stop here for today because I noticed that now we're getting into something that's going to take a few minutes to explain. So see you in part 2.